Find the derivative when you have an inverse trig function. No one likes these, but here's the derivative of the inverse sine. All right, d dx of inverse sine. By the way, you might see this written out as arc sine with a little arc in front of it. Same thing. Of whatever, I'm letting u be whatever, is going to be the derivative of the inside. Okay, so the derivative of 3x, that whatever, over the square root of 1 minus whatever squared. So a little bit of chain rule action going on. You can memorize like 1 over this stuff, but I don't know, I would rather just go straight to the chain rule stuff because more often than not, you're going to have to use chain rule with this. So what this is going to look like is f prime of x is going to equal the derivative of the inside. So since the inside is 3x, the derivative is going to be 3 over the square root of 1 minus, in parentheses, 3x squared. So cleaning this up just a little bit more is going to be 3 over the big square root of 1 minus 9x squared. Now, if you're thinking, ooh, let's do difference of squares. It's not going to help us. I know you're thinking the right thoughts. Difference of squares isn't going to do you any good because they're going to be two different parentheses, so you can't take the square root of them anyway. So we're stuck with this. This is our guy. And our answer is not so bad. Not so bad at all. M&M. Find dy dx if y equals the inverse secant of the square root of x. All right. So the inverse secant's derivative is going to look a little something like this. All right, inverse secant of, we'll call it some random u, so this also incorporates the chain rule. You're going to take the derivative of the inside stuff, which is going to be the square root of x. We'll deal with that when we have to. In the denominator, you're going to take the absolute value of the inside stuff as is, and then a big square root of the inside stuff squared minus 1. All right, so let's look at this in kind of 3 parts. We have the u is going to be the square root of x, all right, because we have that. So the u is going to be the square root of x, but I'm going to call it x to the 1/2. Okay, so if looking at this at 3 parts, u prime is going to have me use the power rule, drop down the 1/2, subtract 1 from 1/2, and I get negative 1/2 as my exponent. Cleaning that up a little bit, that's going to look like 1 over 2x to the positive 1/2, and that's going to look like 1 over 2 times the square root of x. Hopefully you have this memorized or have seen this enough by now that you know this turns into that, but you know, if you don't, no big deal. So that's u prime. The absolute value of u is just going to be the absolute value of the square root of x. Don't overthink it. But if I wanted to find u squared is going to be square root of x squared, which is x. So now that I kind of broke all this down and wrote it into different parts, y prime is going to be this put together. So the numerator is going to be 1 over 2 root x, and the denominator is going to be the absolute value of root x times x. So, I'm not sure if it's even worth trying to clean this up and make this look a little bit better. Like, I know we have a complex fraction, but I'm going to leave it like that. I think that's okay. I don't know. Maybe in different problems you might be asked to do the reciprocal. So I guess if you were to do that, you would multiply the top and the bottom by 1 over absolute value of root x. So that would look like this. Y prime equals 1 over. You would have 2. You would have the absolute value of root x. You would have x. You would have root x. It's a mess. So, I mean, I guess all of these are okay, but none of them are great. So, I don't know. It's all good. As the kids say, it's all good. Like and subscribe. Hope this helps. Oh boy. Compute the derivative of f of x equals ln of x minus regular sine x plus arc tan x plus 2 to the x. All right. So nothing crazy, like no chain rules or anything like that to deal with. Except for 2 to the x is a little bit of work, but that's all right. ln of x, so f prime, let's just one part at a time. One part at a time. Okay, ln of x, 1 over x, no big deal. Okay, then we got minus sine x, so that's going to be minus cos x. That's not an inverse or anything like that, so I don't have to lose any sleep over that. This is why I have this section. Arctan is the same as inverse tangent, and so that's going to be, what was that, plus 1 over 1 plus x squared. Okay, memorize that. And let's get my purple marker out. Whenever you're dealing with 2 to the x, that's going to be b to the x ln of b. So I'll put 2 to the x ln of 2. So let's see if we can get rid of stuff. 1 over x is consistent with everything, so that didn't help. But we have minus cos x, so you're plus, and so are you. So those guys go away, so C and E are no longer options. We have 1 over 1 plus x squared, so you're already done. You're gone now. And then my last option is going to be, even though it's backwards, 2 to the x ln of 2 is not u, so I'm going with D for that. All right. So lots, 4 different things to deal with, but the kicker for this one was the arctan, which is also the inverse tan, and that's what this section is all about. What is an equation for the line tangent to y equals the inverse tangent of x at x equals root 3? All right. The derivative of the inverse tangent of x is going to be 1 over 1 plus x squared. All right, so since I have this, right, I know that y is going to equal, or y prime, so y prime is going to equal that. I care about what happens at root 3. Now again, the equation of a line tangent means derivative, so that's why I did this. So now I'm going to plug in root 3, and what that will do is give me my slope of the tangent line. Okay, so my slope of this tangent line is going to be 1 over 1 plus the square root of 3 squared, which is going to be 1 over 1 plus 3, which is 1/4. So my slope is 1/4. All right, my slope is 1/4. Now what I have to do is it gives me an x value, but it doesn't give me the y value. Should I plug that into the derivative? No. If I want the y value, I'm plugging that into the original equation. So what I have to do is find out what y is when I take the inverse tangent of the square root of 3. So this is pre-calc stuff. And if you remember it, you get pi over 3. All right, so this is what I have. I have a slope now of 1 over 4, and I have a point where the x value is the square root of 3 and the y value is pi over 3. So using point slope form, all right, y minus y sub 1 equals m times the quantity x minus x sub 1. I can label um, it's already labeled. I can label ux sub 1, y sub 1. And that gets me y minus pi over 3 equals 1/4 times the quantity x minus the square root of 3. So y minus, not u, equals 1/4. So u, x minus the square root of 3, my guy is e. All right. So pretty tricky stuff. Okay, pretty tricky stuff. But yeah, there you go. Inverse stuff. It's great time.